So we know that a magnetic field is produced around bar magnets and around the Earth like this. But there's another way to make a magnetic field. Take a piece of wire like this, pass it through a piece of paper like so, and then sprinkle some iron filings on the piece of paper. At first you won't find any pattern. So what you need to do is connect that wire to a circuit and then let some current flow through the circuit. So close the switch, and now current is flowing through the circuit. Give the paper a tap like so, and you'll find a pattern being formed around the wire. This shows that there's a magnetic field being produced around the wire. This is because there's a current going through the wire, and the current is producing a magnetic field around the wire. Another way to show this is to get some compasses and put them next on a piece of paper like so. Right now they're all pointing in one direction because there's no current flowing through the wire. They're all pointing towards Earth's north pole. Okay, they're aligned to the magnetic field of the Earth because that's the strongest one around at the moment. But if I close the switch and allow a current to flow through, that's going to produce a magnetic field. And now the compasses are going to be aligned to the magnetic field of the wire. Because they're closer to the wire, there's a strong magnetic field around it, and that's going to cause them to align to that. Okay, so they're aligned to this. The magnetic field around a wire looks like this. Okay, it forms concentric circles like so. And as actually you can see that it's getting weaker with distance. It's very strong near the wire because you can see the magnetic field lines are close to each other. The closer the lines are to each other, the stronger the field. And you can see further away, it's getting further apart. That shows that the magnetic field is getting weaker with distance. To determine the direction of the magnetic field around the wire, you can use the right hand grip rule. So get your right hand and turn it into a grip like this. Okay, so point your thumb in the direction the current is flowing, and your fingers would curl around in the direction of the magnetic field. So for example, here, so current is going upwards, so I'm going to put my thumb pointing upwards in my right hand, and my fingers will curl around like so. So that tells us the magnetic field is going around in almost an anti-clockwise manner like this when you're viewing it from above. Okay, so let's actually look at it from above so it's a bit more clear. So here on this piece of paper on the diagram on the right hand side, the current is going out space, so it's coming towards you. So if I put my right hand like this, my thumb is pointing out the page coming towards me, okay? Then my fingers are curling around in an anti-clockwise direction. So that shows the magnetic field is going around in an anti-clockwise direction. Let's try with this one here. So here we've got a battery connected, and we need to label the positive and negative ends of the battery so we can figure out the direction in which current flows. The positive end is the longer stick, okay, and current flows from positive to negative. So the current is going around like so. So we need to get our right hand and point it downwards because the current is going downwards on the piece of paper like this. So that means it's going to go around in a clockwise manner like so. Okay, so initially if you look at it from above so that it's a bit more clear, let's point our right hand into the page. So it's going around in anti-clockwise, clockwise direction like this. Okay, so it looks like that.